Okay, welcome everybody. Thank you all for joining us. I, I'm excited to have this webinar this afternoon. We are doing a joint webinar here between JuliaHub and PumasAI. My name is Matt Bauman. I am the Director of Sales Engineering here at JuliaHub, and I'm delighted to introduce and present to you all Vijay Ivaturi, the CEO and co-founder of PumasAI, who has worked deeply across pharma and working with us at JuliaHub, as well as with many customers, and we'll be talking about that throughout this discussion. Also presenting today is Phil Burns, a sales engineer here at JuliaHub. So thank you everybody for joining us and attending. We will be recording this session. So following the webinar, you should be getting a recording link to go back to it. But we're also hoping for an interactive session. So please feel free to type questions in either the Q&A or the chat, and we'll monitor that and come back to those questions at the end or possibly in the midst of the discussion. So thank you all. And with that, I will hand it over to you, Phil.
Thank you so much, Matt. So thank you for attending. We have a really good panel here. Vijay will give a few words in a few minutes that are very specific to the needs and applications of JuliaHub to the pharma workflows that are addressed in this presentation. My focus will be mostly on the platform itself. By platform, I mean JuliaHub, the platform in which you will be working. Vijay can definitely guide you on how to best use it with respect to Pumas and other applications. So with that, I'll get started in the first slide. So just to get a brief orientation, and I don't want to belabor this, but I do need to mention it for sake of completeness, is that this whole JuliaHub revolves around the Julia language. Don't fixate on this, please, but just where does the Julia part come from? It's from the Julia language. It's a computer programming language, very powerful and increasingly popular. Now, on top of that is something called SciML. Again, no need to fixate on this, but from SciML came Pumas, right? This is the product that Vijay and his colleagues have developed and which operates up using the Julia language. There's also the Julia Sim, which is parallel to that, solves a similar suite of problems, but all of these operate on JuliaHub. Okay, now this is, with respect to what I'm presenting, quite relevant because JuliaHub is the platform on which, you consider it the substrate of your Pumas applications. Now, that does extend, however, in the pharmaceutical world to other environments. And those would include, you see it's getting wider, such as RStudio, right? So specifically like Metrum, BBR, various dev tools related packages will be operating in the RStudio environment, which is not using the Julia language. It uses the R language. You may have legacy packages, especially with the visualization tools and workflows. That does work under JuliaHub. Furthermore, you have non-mem, right? Who could go anywhere without non-mem? Yes, indeed, we have non-mem. And not only do we have non-mem, but we have the ability to execute batch jobs within non-mem. We'll show that later on. And then with respect to the entire suite of pharma applications for the pharmacometric workflow, we have things like this Phoenix, Licksoft, etc. And I guess at this point, I'll let Vijay contribute a few words to explain in better detail than I could the ecology and topology here. Thank you.
Thank you, Matt, and thank you everyone for attending the session today. I've been working with the folks at JuliaHub for the last almost 8 years right now, and it's been a pleasure to grow along with them and see how the products both at PumasAI and JuliaHub have developed and come to this level of excellence and service that we provide. So just to give you a very brief background, at PumasAI, all the work that we do, the product development and the consulting work is being done primarily on the JuliaHub platform, which is an integrated solution platform that is suited for a pharmaceutical modeling and analysis workflow. whether you're interested in, you know, working directly with Pumas-based workflows, and that is what JuliaHub is primarily optimized for, or whether you want to do your traditional pharmacometric workflows using RStudio and non-mem or other Windows-based applications. All of them stay together in one environment, talking to the same file system so that the interoperability is quite seamless. Now, the uh, the obvious question is, okay, you're right, you have Pumas, which is written in Julia. This is JuliaHub as a platform. So why provide all these other tools? And the simple answer is, you use the best tool to answer the questions that you need to do for your drug development solutions. And most of our existing scientists and colleagues in this space, everybody has their favorite tools and want to have continued access to these tools even after even though they have been using Pumas. So the toolings that Phil is going to be talking will be demonstrating today will be talking about how Pumas works in JuliaHub, how non-mem works with RStudio, and within an R environment or within a Pumas environment. And there are hundreds of different ways to run non-mem. Some people prefer Perl Speaks non-mem, which is the tool from Uppsala. Some folks prefer BBR, which is an R package from Metrum. There, some people prefer awk. So they just and some people prefer graphical interfaces. So it just depends on what the as a person likes, and we strive to provide access to most tools as possible so that you can uh, best perform your workflows. And just to give you a final thought on this, for the last 5 years, PumasAI has grown tremendously with our collaboration with JuliaHub, and we've done multiple regulatory submissions, and our products are, CFR Part 11 compliant, GXP compliant. The platform itself it is, and we really hope to give you over the next two webinars an oversight into a deeper insight actually into how the platform is set up and how the integration of your pharmacometrics workflows can happen. Phil?
Thank you, Vijay. So carrying on to the next slide, I'm going to talk about now a little bit of detail about the platform itself. And I think these are very relevant to scientific workflows, pharmacometric, or anywhere you need to reproduce results. And there are specific challenges in development environment because in software engineering, typically reproducibility is not a criteria, right? Like no one's going to say, "Oh, can you reproduce that program you wrote 10 years ago?" Well, that's sometimes is a thing, but not to the extent that is, especially with respect to regulatory compliance. So to that end, we've invested substantially in creating a platform in which reproducibility is easy, for lack of a better word. So what do you need for reproducibility? You need applications. You need to specify on what machine is your environment running, right? The application should be almost seen as like a computer. So I imagine a cloud instance, or just for sake of simplicity, a laptop on your desk. You could consider that your application. With that application then comes an operating system and a specific program running, be it RStudio, Pumas, a Windows workstation with, say, Phoenix or Elixsoft, etc. Then comes collaboration. This is another dimension to reproducibility, right? I collaborate with other people in my organization, and I have to manage those rights. And we use the SSO rights from your organization to determine who with whom you work with on a given project. And then lastly, data, right? So you have to have data versioning to know what data is relevant. And this is of course key to validation and reproducibility is what was my input, what is my output, right? Is this a derivative of something else? Is there any specific metadata or tagging I should have with this data set? These are the three key pillars on JuliaHub for reproducibility. I'll go into a little more detail. So with respect to applications, what is an application, right? It's kind of a loaded word because conventionally you say, well, like, Microsoft Word or Excel are applications. Yes, they are. In our context, it's a little more than that. It's a little more extensive because we're including the machine. So imagine if you would say your laptop turning on and launching Microsoft Word, we would call that the application. So it's quite a bit more than just say the application that you click on in your desktop. And to that extent, it's really nice, however. And why do we bother with these being able to toggle the machine at such granularity? As you see for here, for example, we can toggle the number of CPUs involved. We can toggle if it has a GPU, we toggle how much memory it's using. We can toggle how long it's going to run, or if we want to constrain compute costs in any way. So yeah, we could decide if it's a single, if it's a distributed process or not. There are many things we can toggle on the application side with respect to the computing environment. And that's important because one, some jobs, some computing tasks require a lot more resources than others, and you want to provision that accordingly. It's also important because some of them don't, and you want to also provision that accordingly so you don't waste money, right? So this idea that you can, rather than have essentially overkill for small jobs and out of memory and running out of resources for large jobs, we provide that granularity of control within an application. This is quite important, and personally, I have encountered this as well. As when I'm running an application, I need to make sure to have sufficient resources for it. One cool thing about JuliaHub, of course, is that you have essentially visibility into the resources utilized or consumed by a given application, which is nice. So you can actually get a real good sense of, oh, how much memory is it using? How much CPU is it using? So you have an idea that if I need to in the future provision more, or I can maybe get away with provisioning less. You have that available to you in the platform itself. I'll show that to you later. Projects are really important because they're our preferred method for controlling collaboration. So we talk about collaboration, means the header, right? And under that is projects because that's our mechanism for doing it. So when we collaborate within an organization, conventionally, we do it through the project entity. The project encapsulates both code and data. Okay. So we do make a distinction. There is a file system that you can think of, and there is a file system behind the scenes, but we do make a distinction. One can make the distinction between code and data. We're not going to do that in this demonstration, but typically one can make that distinction, but we are not going to do that here, and you don't necessarily have to make that distinction. So you could consider it like your file system, so to speak, but you're going to manage access to it using your organization's SSO rights. Right. So the access rights given by your organization's SSO will one-to-one port over to JuliaHub. So if I can share with you internally, if I'm in your organization, I have the right to share things with you. I will be able to share projects with you. If I don't, I can't. I won't see you. You won't be visible. So that's how we manage it. So this is how we're able to not only populate a project and create it, but also manage access and control, I should say, within an organization. So the control of the development of the project and its trajectory will parallel precisely that of the existing organization. There's nothing you need to change or add. There's also within the project entity, and I will show this also in the demonstrations, a lot to show, is the ability to do things such as add metadata, configure how I'm going to launch the entities within the project. You can set something called like a default application and variety of other options. So they're very flexible and they continue to evolve nicely. And then lastly, I just want to touch on data kind of informally here. We do have this thing called data sets. We're not going to address it here, but they do exist. You're going to see them in the presentation. I am not going to really use them, so don't fixate on them. But just know that the concept behind data sets is versioning. It's about really rigorous versioning. So the idea is that it's a persistent store. You can't delete data sets, so to speak. Like we want to be able to have them as essentially as like an archive, and they are auditable. They're they're fully compliant with validation. And as you can see, you have the ability to toggle a data set as public, private, or common to an SSO group within your organization. But again, this is not going to be a priority of the presentation. Now, with respect to applications, the applications, as we talked about, the applications are like little computers that come with a program on top of it, right? Like I said, imagine you open your laptop and it only runs Microsoft Word, right? Or runs Excel. that's kind of like the application. So you configure your laptop, how much RAM, how much memory you want. You say, okay, I'm going to run a big program. I'm going to run some giant simulation, you're using Pumas or non-mem. I'm going to have a lot of resources. If I'm doing some little R script, I have far fewer resources. That's already been explained, but now we have to think about, okay, I told you about provisioning the application, selecting the program that's going to run, giving it the resources it needs to run those programs, and maybe constraining it with respect to costs. But finally, where does the stuff sit? Okay, like we all work with file systems at the end of the day, at some form or another. At the end of the day, we work with file systems. So we need to know, where are these entities or the assets going to sit with respect to the application that we're running. And as we see here, there are 4 places. And again, I don't want to belabor this. This is a little more technical for later, but there are 4 places where they sit. And in this case, we're going to be using the projects. Okay. We're going to have everything sit within a project. So the project will be the folder, so to speak, and it is an actual folder on the JuliaHub file system, the cloud file system that you can change into and just treat like any other folder in Linux. But there are other places as well. There are data sets that I mentioned. There's JuliaHub Drive, which is basically your personal network drive space that's persistent. It's not scoped in any way. The only thing is with your personal space is you can't share it. So the distinction I make between projects and data sets is I can share a project with someone. I can share a data set with someone constrained by SSO control. But on JuliaHub Drive, I can't share it with anybody. Okay, so it really is like your Scratch space. I used it myself for Scratch work, maybe local demos, maybe to store some large file, whatnot that doesn't need to be shared amongst my colleagues. Anywhere else on the file system, just as a technicality, is not persistent. And that kind of makes sense in terms of efficiency, right? You don't need to store everything everywhere. And also, to be honest, you don't want to be what we call stateful. You want to have a consistent application environment every time you start it. And if you start storing everything or too much information, when you load up the next time, you may forget, wait a second, did I toggle some setting and now it's not behaving the right way? Because as we recall, the goal is to be reproducible, right? So when you're launching these applications, I really want to isolate as much as possible things that I don't want in my environment. And that's what the application design does, is that we isolate the code and the data from the environment in which we're working so you can actually reproduce these results 5, 10 years later. So today, we're gonna have a quick little, well, actually not such a quick demo. We're gonna have a fairly straightforward demo. I'm going to just show the project lifecycle, where you create a project, add some assets to a project. I'll then run an existing project from within the IDE. I know the agenda was exclusively interactive, but I may touch on batch jobs just because I can, and we maybe go into those more in the next session, but they're quite fun. And then I'm also going to go into RStudio, and if we have some time, I'm going to jump into Windows Workstation. So with that, I'm going to now switch to my environment here. So I'll start with the home page. We're on the internal server, so this is the internal JuliaHub instance. Okay, if at your company you would have this internal would actually be your company name, right? So if it's Joe's Pharma, it would be joepharma.juliahub.com. Okay, so that's how it looks. So this and the things here would be scoped to your organization as well. With respect to applications, there's an application carousel, right, across which I can scroll through applications. Some of these you may you may elect to have in your organization. Some you may not. That's up to you, your colleagues and your managers. And I can also scroll down and see the available projects to which I have access, my jobs. As you see, I got some jobs that are running. So it's a nice like a command center, right? I know what's going on. Jobs that I stopped. New packages, this is not super relevant. Updated packages. And then what would be relevant for people in this space are recent batch jobs, right? So you have your own section down here, and this is all in the home page. So if you want to quickly scan the state of what's been going on, as you can see, I've been running a lot of batch jobs on internal relatively recently for obvious reasons. You can get quite a bit of very relevant information from your homepage. The next one is applications. This is where we launch those little computers I talked about, and I can provision specific resources for a given machine. And I don't need to do it over again because I've actually pre-launched the Windows workstation here. But if you can see something similar, if I were to say, I can actually, when I launch certain instances, it will actually prompt me for how many resources I want to commit. So I actually may have the option. And you'll see it later of how much memory, maybe number of CPUs, essentially the amount of money I want to spend on the job. And I can toggle that custom. There's also a space here for my applications. These are custom applications you may add later on, which I've done myself. This is just a little dummy server I use for diagnostic purposes. You can add applications here. These would go through a conventionally some sort of Git forge. Again, outside the scope, but just for the more technically inclined, it's there. Notebooks, we're not going to touch. That's just our variant of Jupyter Notebooks, but it's built in. Now, here's projects. This is something we will touch, and it's very important to us. I have a pre-existing project, right? This is the one I'm going to run now. However, I would like to show you just how would I create a project? What does it mean? If I click Create Project, what does that do? As you see here, I have some templates, which are quite nice. These are actually somewhat customizable. In this case, however, I'll start with a generic one. And I'll give it a name. I'll just call it, dummy project. Or, no, I could call it something more substantial, non-mem blank, or non-mem dummy. Okay. And this will be my non-mem dummy project because I already have a dummy one that I will show you. I don't want to be using this one. In this case, I can add tags, right? And this would help me for searching and editing. I have two options for how I would share. So recall we talked about sharing projects, right? I can give you access to the project. The question is, how does that work with respect to synchronization? Right? Can we work on the project at the same time or do we lock it? Now, I've actually worked in medical devices myself, not pharma, medical devices. Whenever we worked on clinical affairs things, we would lock files. And right now, I always work with the exclusive editing mode with respect to collaboration. That's like the locking system. I think a lot of us are familiar with that type of workflow. You do have the option, however, to use collaborative editing. That's a little more sophisticated. I generally stick to the exclusive editing. It's simpler for me to track. And then the default application. So this gets to brass tacks, right? Like, what is this project going to like load into, right? I configured I'm setting up this project. If you think about the project, right? It's almost like I'm going to start. I have a computer. I'm opening an Excel spreadsheet, but what's that workbook in Excel that I'm going to open, right? To use an analogy. Well, I want to open something, say, that's going to use RStudio. So I'm going to have stuff that I'm working on that uses RStudio server, some R code, in this case, like some non-mem code. I would hit next. I could add colleagues. So for example, I could add my boss, him, and I can toggle his role. All right. The difference between viewer and reader is the reader has the right to clone it and work independently. The viewer does not. That's the only distinction. But I have these different roles. Editor obviously edit it, and owner basically takes control of the project. So I can give them, say, reader rights, general access. I could again toggle between viewer, reader, and editor. I guess I'd give people the right to clone it. So I'd say reader and continue. And it's going to create a project. Now, this is a new blank project. It tells who created it, the default application, the description, gives me a tag, and the date and time it was created. Well, the time's not displayed, but it's there. If you notice, there's some files hidden. You can toggle. There is a Git forge behind the scenes. And if you also notice, there's something called code and data sets. Conventionally, I would be adding data sets here. So I could do something like this where it says attach data sets. I can attach an existing data set that I have, right? Or I could also import a data set, right? So I could say, so like non-mem data. I say non-mem data for 1.5.mod. We'll make it not going to share with anyone. You toggle the license, and I can upload file. And I'll put some nice CSV file in there. I'm actually not going to be using the data set in our specific workflow, but I do want to show that it's there. So now you see there are two data sets here. This is a completely irrelevant one, but I just wanted to show that I can get that from across organization. Air passenger CSV, that's a version 2. And non-mem data, that's version 1. So you see the versioning is built in. If you click on the data set itself, right, you see that you have the ability to actually add versions from within the UI. And also I can also click here. It says associated projects. So it shows me one advantage of the data set. If I step back for a second, like why do we have data sets? Data sets give you more metadata than a simple file name. If I have a file system and it sits in a folder, I say, okay, I got Theo, the theop.csv. It's in this folder, which is a subfolder of that directory, and right now it's accessed by so and so. Here, I'm able to add a lot more what we call metadata. So I'm able to give a lot of information about this data set. So that's a concept here. For example, instead of saying it's in a specific folder, I can say it's associated with a specific project, which in this case is non-mem dummy. I also have the ability to edit the metadata of the project, right, which we already instantiated before, but I can change it later on. And most importantly, I can add versions, right? So I can upload a new version or using other commands, change the version, and it will automatically increment the version. It will automatically keep track of it, and I will have all versions accessible. So, for example, if I were to have, say, as you see right here, I had just version 1, I can view it. But if we go to my data sets, excuse me, sorry, I lost my path here on the projects. If I go back to non-mem dummy, I click on data sets, I click on air passengers. There are 2 versions, there are actually 3 versions, right? So I can select one of these 3 versions and view them. So that's how the data sets have a nice advantage with respect to versioning. I don't want to belabor this too much, but if you're going to see it, now you know about it. But you don't have to use data sets. You can use files. There are pros and cons to each one, but that's what they're there for. Anyway, back to our project. So I put a data set in here just for sake of completeness, and now I want to upload some files, right? So I could click upload file here. I can upload some code. And in this case, I'm going to need to upload two files because I'm running nunmem, and in our case, we need like a runner script, which is going to run on JuliaHub. So I would have to run, this is the main.jl, this is like the runner script, and then I have to add the actual nunmem file itself. So that would be, this is your .mod file, okay? And then if I were to launch this, and I'm going to show you a more warmed up example, I would be running this runner script will in fact execute the mod file, which in fact will read data from the desired nonmem file. Okay, so let's go into an example. So now I'm going to open up, I showed you how I create a project, right? Now I don't really need it. So I don't delete it though. I just archive it. So it goes away. Now I'm going to go into the actual project. This is the project which we're going to work. I came prepared, so I started this ahead of time. In this case, we'll start with the Pumas demo, and you'll see that everything's here. I have a manifest and project. Don't worry about that. That's Julia's stuff. This is where I'm going to open this Pumas PK demo.jl. This runs the Pumas package, which is extremely powerful, and loads it up in a special IDE. See, when I click connect, it's going to say default app, Pumas. Well, what is that? Pumas is actually this, okay? So it's an integrated scientific modeling, simulation, AI, ML tool. This is very powerful. And it's really good to do it this way because there are other ways to create this environment, this Pumas environment. This saves you a ton of time. I'm talking a lot of time, at least 20 to 30, maybe 40 minutes. So this is a very specialized application for the pharmacometric workflows. And I have to say it's kind of undersold because there's a lot of cool stuff that's been added. And I'm going to show you some of it because there's some neat surprises that are very pleasant to have. So if I were to open that up, right, I would land in something like this. You land into like a welcome page, and here's a Pumas PK demo .jl file. Now, one thing you want to notice is I have a lot of dependencies. I have the Pumas utilities, the Pharma data sets, and data frames meta. These all work out of the box. And I can run them line by line. I hit Shift Enter, and each one of these executes. You see, it just works. Now, because I'm running on JuliaHub and I think I'm going to run a batch job, right? I know I sold interactive earlier, but I think I want to run a batch job. But batch job with respect to which output, right? You want to be able to have a place where I can easily identify when I run these jobs. Like let's go back for a second. I have a job. Look at all the batch jobs I run. Okay? Imagine I have to say, oh yeah, find the result file from one of these batch jobs. Just go find it. Not so obvious, right? I may know which batch job I run, but I may not know where to look. Well, we help you with that. We have this environment variable called results file, okay? And it gives you a path with a specific CSV result. So that's where it's going to be written to. And so if we were to run this code, it will perform the Puma simulation, right? And I guess I'll just start doing that line by line here. I'm going to set the results file. I'm going to generate the data set. Just a little bookkeeping there. You see the code is running down here in the terminal. I assume people are familiar. Most of you probably use VS Code, so none of this looks particularly novel. And what's really nice, though, is I have built-in plotting, right? So these are Puma's functions, and I'm starting to have some of the plots pop up right here. And again, I have the ability, though, to turn this. This is interactive, right? Right now, I'm working interactively. I'm not running a batch job. I haven't set up a batch job. Here's my batch job interface right here. If you click on the JuliaHub little icon and the extensions, this is where I have set up a batch job. I'm not running a batch job. This is interactive. This is all interactive right now. I'm just doing Shift-Enter line by line. Let's create a model. Okay, let's set up the initial conditions. Let's do a fit. And okay, now it's thinking. Give it a second. So, and then we'll plot that and move on. So one cool thing is I'm showing an interactive workflow, right? And I'm showing an interactive workflow and essentially what is the Puma specific VS Code instance running on JuliaHub. I will also have the ability to do this in RStudio and other environments. The distinction, however, is that within the this development environment, which is, again, this is the Puma's application environment, which if we go back to applications, that's this one. I have the ability to send off batch jobs. So I don't have that across all environments. So for example, in RStudio, in Windows Workstation, if I'm trying to use Lixoft or Phoenix, it doesn't quite work the same way. I don't have this ability to fire off individual batch jobs that I can actually manipulate and control like I would from one of these. So if you want to do that, you want to launch that from within this environment. Okay, let's see. It looks like we're ready for some plots. Voila. Okay, this looks all pretty successful. And let's see if it's going to let us to write it. I think I already have it there, so it may complain about writing it again. Yeah, because it's already there. So yeah, okay. So that's fine. But the main thing is that I have the ability to run this here. So now what I want to do is I'm going to set up a batch job. Okay. So let me do that here. I'm going to set up a JuliaHub. I'm going to set up a batch job. I'm going to click use the current file. And let's see. It gives me a bundle directory. That's essentially it's a technicality you don't need to worry about, but basically you want to choose the directory that matches where the program is being run from, so to speak. So you see the file sits in it's slash Pumas pk demo.jl code Pumas. Okay, that sounds about right. Now again, for a batch job, we can toggle it, right? So node type, here the number of processors and amount of memory. For this, 4 gigabytes is probably slightly undersized, so I'd probably want 16. I don't need to run a distributed process. The time should definitely not take you that long, maybe 1 hour tops. And then I have to choose the right image, right? So I would want to use, say, the Puma's 2.6.1 image. Now, here's what's interesting, though. And this is what's really nice. And this is compared to other platforms. I mean, I'm thinking R, frankly, like toggling the image like this is not so obvious, right? Like if I want to go into, say, RStudio and toggle a different version of R and recreate that environment, it's frankly a lot more laborious than doing it here. So right here, I can literally choose my image. So I say, oh, I'm going to run the 2.61 version of Pumas or the 2.41. So this is really convenient. I give it a job name and I can start the job, right? I guess I'll just, for this, for this, I'll just comment this out because it's misbehaving. But I'll start the job here, okay? And that's going to give me a batch job. Okay, so I went from an interactive run, and it started successfully. I went from an interactive run, right? And now I was able to work interactively and in the same environment, one place, go straight to a batch job. Okay, so let's see, where does that show up? Let's click on jobs. Oh, I didn't cover this at all. Good point. Jobs are where the applications which are running are listed. So remember, I spun up a Pumas instance, right, to run the Pumas application. I spun up an RStudio instance, which I haven't touched yet, but that's to run an RStudio application. I started a Windows Workstation job to show you some Windows Workstation stuff, which I did briefly here. I mean, yeah, here it is. And we can go. I don't know if we have time to go much further. And now I just shut off a batch job for Pumas, and look at the type. It says Pumas batch. Okay. So this is there's an extra dimension here, or I guess maybe field if you want to be more technical, which is I not only have the name of the job that's running. So the job is essentially an application in motion, which is a computer with a specific programming running over time. That's a job. So there's an application in motion here. This is, however, is a batch job, which is distinct from all these. Not a single one of these other ones are batch jobs. These are all interactive jobs. So my RStudio session, which is here, this is an interactive job. My Windows session here, this is an interactive job. Although it is possible to persist logs and projects here. I've done that with Phoenix, but I don't want to go there right now. But this is a specific batch job. That is imperative with respect to rerunning the job. I am not able to rerun interactive jobs, obviously, because they're interactive. But batch jobs I can. And when the batch job completes, you're going to see a little rerun button at the end here, and that's how you'll rerun that actual project. So when the project's complete, so for example, if I were to say stop, RStudio or any of these, it goes from an active job to a completed job. And if you notice something, these failed, but not all of them did. But I had the ability to rerun. And that's what will happen for all your batch jobs. You will have the ability to rerun. So for example, this was a successful one. I could just rerun that with one click of a button. Right? So when we talk about reproducibility, that's it right there. I had it as a non-mem batch job and a Pumas batch job. While these jobs are running, let's see here. Oops, go back. Okay, so these jobs are still running. I can go back to my IDE and I can say, you know what? What about non-mem? Right? I have a non-mem project here. I talked about non-mem. I want to maybe shoot off a non-mem batch job. I can do that too, right? So likewise, I can run this non-mem batch job through this control file, which is written in Julia, like so, Shift Enter. Nothing here that's particularly interesting. It's staging the environment, setting up the number of processes. So this is setting up the applications, this is setting up the number of CPUs, it's setting up this finding where the command is. It's going to run the execute command, which is, if we are in the environment here, right? Just to prove that non-mem is here, right? And we have PSN as well. So we have PSN and non-mem running here. So that's another thing too, is that this IDE is loaded. It's ready to go. I not only can run canonical execute right from non-mem, but I can also run PSN, as I just showed. Oops. Okay. So let's see here. Let me get this to work. And now this little non-mem command, it just constructed this command to run mod 5. All right. Remember the project I made earlier? I had the run5.mod file. I'm going to log this, give it a whirl, and yeah, toggle that. Okay. Collection's empty. That's fine. Didn't run. Okay. So now what I want to do is I want to say, let's make this non-mem interactive job. Let's try it as a batch job. So I go down here to JuliaHub, All right, I'm gonna instead of saying, remember this is this PK demo. Well, I don't. I want to use this main.jl for my runner. That's a nom file, and it automatically gave me the correct bundle directory. The resources here, 16 gigabytes is good. It's not distributed. Don't need a ton of compute time. Image option, however, this I must toggle. So this I set to nom batch, right? And I start the job. Okay. So now I have the nom batch job fired off from this IDE. I want to contrast this from which I can fire the batch jobs to say RStudio, right? Now RStudio, I launch RStudio I can launch RStudio from a project. I can launch RStudio from here. So I can say, excuse me, I can just launch RStudio from here or connect RStudio server. You see the down caret? I had my default app as Pumas, but if I hit the down caret, I can connect RStudio. In RStudio, I can pretty much do many of the things I can do in the other IDE, in the Pumas IDE. However, I don't have the ability to fire off those batch jobs. That is like the main distinction. So conventionally, what do people do here? Well, they do things that they do in RStudio. I mean, let's look at the library, right? Like we have some really nice things, like we have DevTools. When you load up RStudio, DevTools is there. See, it's right there. Oh, how about this guy? Boom, right there. So, but that's an R itself. So if I wanted to say, for example, with a library BBR, and I wanted to then run BBI version, right, just to prove that it works, it's ready to go. But in the terminal, right, same thing, execute to show that it's there, and I can also show ESN-MN version. So it's there, it's ready to go. However, the workflow is slightly different because when I work with the project interfaces here, I am working more with a conventional file system. You know, I load it into the project. I have the code from the project. It's not in Pumas, but my interface is very different, and my reproducibility workflow is quite different. It's possible to make it reproducible, but it's very different. And frankly, possible is a loaded word. I would say, practically speaking, if you want reproducibility, work with this environment. Okay, this is the environment which you want to work. You don't want to be working within, say, RStudio to make a batch job. You want to work within the Pumas IDE to do batch jobs for non-mem or whatever other image you select here. I'm going to jump quickly now to, I don't have tons of, I'm actually running, I'm actually out of time, but I just want to show that this does work. I think that's important to show it works. My favorite one to run is Phoenix. So I can load Phoenix. Oh goodness, come on, be quick. And I created a project earlier, a trivial project. I added some data to a Phoenix project. And I just want to show it can load, right? I'm not going to give you any insights or deep thoughts on this, but it does work. And oops. And despite not having a license, I can actually load something. So if I go to desktop, my drive, in this case, I left it on my personal drive. This is a case of using my personal space, so it's not like a project or anything. But it does work. Okay, so I create a Phoenix project. It does have traceability. It can generate an audit report, etc. Like there's a timestamp from back in March when I made this. So that works. The user and things like that can eventually be toggled sometime in the future. But this works. So if you're using tools in the Windows workstation, you have access to all of this for these interactive workflows. And some of them can be, if you are very, very careful and very graduated in how you work with them, can be reproducible to some extent. Okay, I think we should open up the floor to questions.
Yeah, thank you so much, Phil. This
My
is
pleasure.
great. I thank you all for your attention here, and please do type in your questions into the Q&A box. I should be able to pop up a Q&A. We'll answer them live. I have a few questions here. One is specifically about licensing. How does that work? And I can handle that one. So there we work with your teams to embed your licenses. So it's a bring your own license model for these third-party tools. For Pumas, we work directly with you in getting those licensed. But for the other third-party tools, you bring your own licenses. Another question here is how much time does it take to onboard folks to JuliaHub to run pharmacometric workflows? And Vijay, I think that'd be a great one for you to handle.
Yeah, thank you. And Phil, thank you for the really nice demo.
Thank you.
So typically, with a platform like JuliaHub and anybody coming into PumasAI and getting on board, it's quite smooth. And for those of them who know modeling, the ability to launch an app and get started in an interactive job is actually quite simple. There is hardly any time to get started there. Now, at PumasAI, we have a very sort of a higher standard to make sure that all our work is reproducible, not only through projects but also through our own version controlling and Git-based workflows. So that is the only part where we insist that folks follow a proper methodology. But from a platform perspective, the ability to log in, to access, to maintain the files, to look at the systems, that's all pretty smooth. And I don't see once they see the SOPs, it probably is less than a week to get up and running in full pharmacometric workflows for them. Yeah.
Great, thank you. Other questions here?
Can you talk, if I can, Matt, ask, if can you talk a little bit about there's there's a question maybe you want to answer first.
Sure, we can handle that. Image, so when Phil was speaking, so the question is, image, is that referring to a Julia image format? Is it like a JPEG or a PNG? In this context, what we're talking about when we speak about the image options here, or often in the context of a cloud computing system in general, images are the it's kind of like your hard drive. It's the state of the machine that you're working with. And so the technical term there is a Docker image. That's the technology atop which we live. And so that image there is not the typical images that you're used to, but rather core infrastructure. And so the different image options that we talk about there, that's going to be the bundled software that comes with them. So when you click on that image dropdown, you can see there's different versions of Pumas that are bundled in that environment, or the ability to have non-mem licensed for your company in that environment with a particular version, and all of the dependencies there that are known to that we can then encapsulate, and it's exactly what powers the reproducibility. So yes, thank you. Vijay, you were going to ask another question?
Yeah, I was just going to say if you could throw some light on the platform features with regards to security, compliance, and anything that's always related to when you're in a healthcare space, or I mean in any space for that matter. Could you talk a little bit about the efforts that JuliaHub has and what all the offerings that you have in terms of trust and compliance?
Absolutely. Phil, if you would want to navigate to trust.juliahub.com, this is our trust portal where you can find lots of information. Some of it is public, some of it is private and behind an NDA, and you can request access with that button at the top. But it's there that you'll find our security stance, the encryption everywhere, both in transit and at rest, our SOC 2 certifications, our understanding of working with other requirements. So we are fully versed with working in the context of FDA regulated industries, and CFR Part 11 compliance, and the all of that, what that entails. And so you can find a lot of information here just on our trust site that can help you navigate the process of onboarding JuliaHub with your IT and security teams. When it comes to QA specifically, we feel like we're in a really good place where we have a validation bundle that we can provide to our customers that allows you to work with your quality teams. We help you, vault our IQ and OQ documentation that certifying that the platform is working as we expect it. We also help work with you to build out process qualifications, and that can be tailored to the workflows within your team. So that way you know that the platform and the software that's on the platform is working as intended. So that's a very long and large question. It's a very large, large problem, but we feel like we have a very good understanding of what's required there, and have worked with numerous customers in developing a fully validated workflow for their pharmacometrics.
Thanks, Matt.
Are there any questions? I can keep talking if that's okay.
Yeah, you want to show the jobs that you submitted live and
Yeah,
put it here?
hooray, they look like they worked.
Yeah.
So this is the non-min batch job. Again, the option to rerun it. As you can tell, the submission was made during the presentation, and likewise the Pumas one, again with the action to rerun it.
Would you want to click into one of those and
Yeah,
demonstrate what's on the inside of that tin?
for sure. So in this case, I have I guess you could call it the metadata, to sound fancy, of the job. So remember we talked about application, so the machine type, these are the resources committed to it. When it was started, status obviously completed, the ID, which is mumbo jumbo, the mode, which for these more, I guess, or less intensive jobs, it's going to be single process. It won't be a distributed job. That's why processes are 1, workers are 0. The type of the job, which actually is very important, which is a batch job, and how long it took to run, duration. Now, these are the input files. This is kind of technical. You don't need to worry too much about it. Here are the output files. I didn't toggle in this case a results file, which otherwise would show up right here. That's fine. You have the metrics here that show you the utilization. This is what I talked about in the very, very beginning. Like when you're trying to size your jobs, right? Imagine you buy a laptop that doesn't have enough memory, right? I actually had this happen to me yesterday. I sent my job to 4 gigabytes, right? I was like, I don't need a big one. And I had an OOM. Right. So, well, you see it right here, why that would happen. So this allows you to talk through threshold your resources correctly and not undersize it. Goes over 100%. I guess that's cool, right? More for you. And then, of course, the logs for diagnostics and for evaluating. This is, again, a little technical. You can actually add logging commands to your code, which if you onboard, you can go through all that. That's very nice. And it gives you a way to what we call have like static logging, essentially. So as your program is running, you don't have to query your program. You don't have to build an interface. You can just look at the logs and parse out the relevant things there. And in fact, you can actually filter by logs, right? Oh, excuse me, not by log group, but by level, right? So like I said, I just want the info logs. I don't need it. I don't care about the bugs or whatnot. I just want to see what's been emitted as info. So that's kind of a nice thing too, is if you're just scanning a program and you have a practice of using info logs to track the state of a program, you can filter that very easily by using the log level. Yeah.
Great. Thank you so much, Phil. And
Mhm.
thank you everyone for attending this session. I think this has been a great session. If you have more questions, please don't hesitate to reach out to any of us, either at JuliaHub or at PumasAI. And yes, thank you so much. Any last words, VJ?
No, thank you so much for attending. And yeah, as Matt said, reach out and if you just want to give it a try, just go to juliahub.com and create a free account and give it a shot. You'll get the feel for the platform, and you really will enjoy the smooth interface, and you'll get a feel for what it is all about. Right?
Great.
Thank you.
Thank you so much.
Thanks, guys.
Thank you.